With a rapidly increasing SA population, coupled with an increase in electricity usage, Eskom felt the pressure to build more power stations. This was at a time when existing generating stations were aging and approaching the end of their operating lives. At a time when electricity demand increased by each passing day. At a time when load shedding was starting to sneak into communities. The pressure was real. And because of the pressure, Eskom launched the 80 billion rands Medupi project. 80 billion rands. The kind of number your calculator double-checks. Medupi was seen as the solution. The nation's survival largely depended on it. To avoid a nationwide blackout in future, Eskom had to get it right. But the project would go on to face a series of technical challenges. Challenges that needed technical solutions. Construction was supposed to take only 5 years, not the 14 years they ended up taking. The station was supposed to cost 80 billion rands, not the 200 billion they ended up needing. And, as a result, the project ended up affecting every single person in SA, with the country experiencing its worst blackouts ever. The project ended up becoming a big learning curve. It was a disaster. Late 90s. Eskom did a quick sanity check on its ability to continue providing electricity to SA. As they did, they quickly realized that to continue surviving, SA needed more electricity. Older generating stations were not aging like fine wine. They were all approaching the end of their operational lives. An operational life is more like a best before date, but for electricity generating stations. Existing stations, at the time, were living on borrowed time. As the aging stations operated in heritage mode, the population was growing rapidly. This was not good at all. As they continued with the sanity check, the company also realized that most of the existing power stations have had deferred maintenance, which is always a recipe for disaster. Because of the deferred maintenance, the company anticipated that at some point, the machinery and equipment at the stations will start to have regular breakdowns. This was not good, because the combination of aging stations and the rising population meant that the nation was going to have electricity shortage in future. Because of that, Eskom launched the Medupi project. Once completed, Medupi Power Station was going to produce electricity for use in houses, mining, industries, factories, and services. The nation's survival depended on its success. It had to be done, and the planning began soon after. After looking for a site, the company began planning. The initial plan was for the installation of 3 generating units. The units were all going to be coal-fired, and were all designed to produce baseload electricity. These units were going to rely on supercritical boilers. And these types of boilers were something that was new to SA. The plan was to accommodate the latest technology and move with the times. But this latest technology had never been used in SA before. Eskom was ambitious. As per the initial plan, each unit was going to generate electricity with a gross capacity of 800 megawatts, giving Medupi Power Station a total of 2,400 megawatts. This was going to be one of the world's largest dry-cooled coal power stations. As a coal station, once completed, big blocks of coal were going to be thrown into a giant furnace. The coal's job, to make a lot of heat. Heat that can boil water and make steam. The steam rushes out and spins a turbine as it does. The turbine will be connected to a generator. As the turbine spins, the generator generates electricity. That is why it's called a generator. It generates electricity. After all that, the steam gets cooled down and changes back to water. The water then gets heated by the coal. Again, repeating the entire process until someone switches off. In simpler terms, that's how Medupi was supposed to generate electricity. But after the initial planning, the sheets did not balance. Eskom realized that more electricity was going to be needed if they were going to avoid a nationwide blackout in future. Due to that, the company added 3 more units to the initially planned 3. This doubled the power station's capacity to 4,800 megawatts. With this done, the company then began raising funds for the project, with the project estimated to need about 80 billion rands. Yes, billion. The project was supposed to take 5 years only, from 2007 to 2012. This was a tough deadline for construction involving new technology, but there was no other option. Failure to finish the station in 5 years was going to leave the country with an electricity shortage, which would have a significant negative effect on the economy. It was 5 years, or nothing. After tendering the project, contractors were then brought in to build the generating plant. Construction work began in 2007. After establishing the site, contractors began doing the foundations. And that is when they realized that the soil and rocks at Medupi site had inconsistent profiles, which led to uneven sinking of foundations, causing visible differential settlement. Apparently, the foundations were designed, while the geotechnical studies were not yet completed. That's like buying shoes, without checking the foot size first. Because before constructing anything, geotechnical engineers must study the geology first. Engineers must know whether the site is made of solid rock, dolomites, soft clays, or mystery mud, with trust issues. Different soils and rocks behave differently. Due to this, foundation designs are always different. So, to design foundations and buildings properly, structural engineers must know what lies below first. Funny enough, this was not done on the Medupi project. Foundations were designed before the completion of geology studies. The foundations had to be redesigned. This amateur error led to project delays and some significant increases in costs. After sorting the foundations, contractors progressed to above-surface structures. This included boiler rooms, chimney, condensers, turbine halls, coal handling systems, and substations. Work progressed slowly, mainly because of technical defects, contractor performance issues, and labor unrest. So, by 2012 only coal handling systems were complete, with critical infrastructure like boiler houses, turbine halls, and FGD for pollution control not yet completed. As a result, the contractors involved could not deliver Medupi by 2012, which was a big blow. What made the situation worse was the fact that when Eskom started building Medupi in 2007, SA began experiencing a huge demand for electricity, which led to some unmanaged blackouts, as the existing grid could not sustain the demand. The problem worsened at the start of 2008, which is when Eskom decided to formally manage the blackouts, and introduced the term load shedding. The pressure to start generating electricity at Medupi was real. The nation needed the station to start operating as soon as possible. As the contractors continued to work on the above-surface structures, the site experienced another technical issue with respect to welding quality. As simple as it may look, welding is tricky. There are welding regulations in construction, with some specifying the level of education needed for welders at a construction site, together with correct welding procedures. Apparently, standard procedures were not followed when welding. The welds failed miserably during testing and had to be redone. To solve this technical issue, foreign specialist welders were brought in, who added additional quality assurances on welds. And again, this led to some delays. Construction continued until 2014, when the site experienced mill problems, as they tested Unit 6 for commissioning. This was after they were done constructing Unit 6, and were testing to see if it worked as intended. Performance audit revealed that the mills were failing to meet technical requirements, which initiated some checks. During the checks, the maintenance team observed rapid deterioration, which was caused by accumulation of slag in the boiler tubes. Apparently, the boiler contractor lacked experience with local coal, having primarily worked with more reactive coals from Australia and Japan. This led to a mill design that could not grind the local coal finely enough. The coal delivered at Medupi had high ash content, high moisture, high calorific value, and inconsistent particle size. These characteristics exceeded what the units were designed to handle. The poor coal was bought from developing mines at a very cheap price, cutting costs. To cut costs further, coal washing was not done. The mills struggled to grind the coal, which reduced coal flow to boilers and lowered the output. As a result of the poor coal, slag began accumulating in boiler tubes, which caused the tubes to fail. This also led to difficulty in meeting environmental limits. To solve this, a specialist defect team was established by Eskom and the contractors. Corrections to accommodate the poor coal were made on the designs, and extended testing was introduced. This helped, but it increased operating and maintenance costs, away from the initial plan. The redesigns were applied to all the units, again, leading to some significant delays and cost increases. At a time when load shedding had an upward trajectory, things were getting worse by each passing day, with citizens tired of blackouts. Not only citizens, even investors began packing their bags for greener pastures. It was not an ideal situation for SA. The nation needed Medupi to start operating. That was the only hope. With that solved, Eskom accelerated the works. In August 2015, Unit 6 was then commissioned. The commissioning was done gradually, but blockages and mill reliability continued to lower the performance of the unit. It was far from perfect. Units were connected to the grid, while defect correction strategies were still being developed. This was at a time when the nation was experiencing serious load shedding. The pressure to start generating electricity at Medupi was at its peak. It had to be done, even with all the technical challenges. After commissioning Unit 6, Unit 5 was then commissioned in April 2017. Unit 4, November 2017. Unit 3, June 2019. Unit 2, November 2019. And Unit 1, July 2021. This meant that Medupi was done. The technical challenges during construction led to significant delays in completion, which then led to a shortage of electricity, leading to the worst load shedding SA has ever witnessed. The project had a lot of challenges. Challenges that saw the overall cost shift from the initially estimated 80 billion rands to over 200 billion rands, depending on who is doing the reporting. But Medupi eventually contributed significantly. The only issue, the station was planned to start operating in 2012, but full commissioning was only achieved in 2021. A 9 years difference. And during those 9 years, the population had grown exponentially, with the demand multiplying. So, by the time they finished Medupi, more than 4,800 megawatts were needed. To avoid a shortage in future, more electricity was needed. Eskom needed to complete another station. The project was experiencing technical challenges of its own at the time. If Medupi was a challenge, then Kusile was the godfather of challenges.